This is going to be a 1S Lipo Megga test. It's towards the end of 2018, and I decided to test the best 1S Lipos around to see if there's been any improvement from the last time I tested them, which was well over a year ago, maybe much longer, and see if there's been any improvements at all. When I tested them last time, as a YouTube somewhere, I found that there's very little difference between them, and you might as well have bought the cheapest one. But now I need to see if they've improved them at all. Before I go into what I'm going to do, I'll just say this is a test to find the best battery for 1/12 scale competition racing at the highest level, and therefore a number of people contact me and say their Lipo is fantastic and just as good, used in drones, helicopters, boats, ready to run. They last forever and give tons of power. Well, I'm sure they do, but I'm only concerned here with the absolute maximum performance for the top end of racing, where every little bit of voltage under load counts. So therefore I'm going to test these under high power discharge and measure the voltage like I did before. Now, before I go into that, I'll just go over some of the other facts. I've got 10 batteries here that I've found in the UK. There are plenty of other manufacturers around the rest of the world, but these are the ones I managed to get at the moment. And one more, the ARROWMAX I wanted to get. I haven't got it yet, but I hope to include it. It's the ARROWMAX 8000. One reason why I want to include that is because it says the only one, the best of the best, no compromise, perfect no matter in stock or mod. It is, if it's related to 1S racing, this is the pack to have. So I want to get it just to see if it is the only one to have. To make a couple of comments. Some of these are called graphene. This IP one says silicon graphene. The LRP says graphene 2, and some of the others I think mention graphene in their descriptions. Now, this use of the word graphene, I did do a video in May 2016 on the Tenergy Ultimate versus the graphene battery, and I think it's just using the word graphene. It doesn't mean it has graphene in it, they just put it in the title. Reason I didn't find any difference back in May 2016, but graphene's been around a while. Do they have graphene in them or not? Well, interestingly, I found an article from GPR Technology Limited, who make batteries in China. This is November 2018, and they go into details here about graphene, saying there is no graphene in RC model batteries. And in the conclusion, and the main thing is, Samsung, the world leader in smartphones, has spent millions of dollars in battery technology to try and improve the cells they put in their phones, and only recently announced that they finally found a way to use graphene that made a better cell. Therefore, if a company like Samsung just figured out how to use graphene to make better cells, what are the chances that RC Lipo factories figured this out close to 2 years ago? Obviously they didn't, and the fact that they say graphene in it means it's not graphene, it's probably graphite. And in fact, another article, if you're interested, from November the 24th in the Times, says exactly that. It says here about no one is using graphene in consumables. They said it's impossible, and that what they're using is carbon, the kind you put in a pencil. And they said, they go on to say that, for instance, a kilogram of graphite, what's in a pencil, costs $1, whereas graphene costs at least $100 for 1 gram. And they go on to say that there's no products in the world that you can buy that has graphene in it outside of research products or things that probably cost a fortune. And it talks about, you can read the whole article if you want. So this thing about graphene is just a name that they stuck on the battery. They probably mean graphite, which is carbon. Anyway, that besides, I've got the batteries here. So let's have a look at a few more differences. A few years ago, the batteries were this size. They're still the same size, all the same size, and I've weighed them and everything. That's all on the chart. I'll show you later. Some of these batteries obviously are the same battery. For instance, the CENTRO and the Fantom batteries are identical in every way. It's the same case. You can see it's exactly the same case, the marks on it, everything, the size, the colour. Oh, they've just got their own stickers on it. I couldn't find any others that were the same except for the Nosram and LRP. Well, the Nosram and LRP are the same company, so it's better than it seems. One's red and one's blue. This one is from over a year ago, and this is the latest one. So it'll be interesting to see if there are any difference between them. Now, all of these are generally around about the 8,000 milliampere mark. That's a 7,008. They're either 8,000, 8,100. Except for the Optipower, I asked them for their best battery. They sent me this 5,600, which they said in their own words is as good as these others. And I'll show you what they said a bit later. So I tested all these. They've all got 4mm connectors still, except for the Fantom and the CENTRO ones, which come with 5mm. All the others still 4. A couple of them have this little extra hole in the middle for your 2mm plug, but it's not connected to anything. It's just so you can plug it and keep it out of the way when you're using a balance lead rather than let it just flop about. This one comes with some blanking things, which none of them have through holes, so when you take them out, you'll just obviously throw them away. None of them go all the way through. And the final point is that although most of them are the plus and minus, plus minus that way round, some of them have only got it indented into the case, so sometimes it's a bit hard to see. It's plus and minus. You might want to put a red mark. This one's got a nice red mark, as a few of the others, but a couple of these have the positive and negative the other way round. As you can see, the IP is plus minus. It doesn't go through, so you've got to use it that way round. And the Fantom, for instance, got plus minus the other way around, and most of them are that way round. 2 of them are this way. The IP and the Optipower are the opposite way around, just that if you borrow one or get one of these and you have one of the others, just make sure you check the orientation. So there's 10 batteries there, 11 if I get the ARROWMAX one. Now just a couple more points before I go over how I tested them. There's the pile of cardboard boxes they come in, except for the Sunpadow, which comes in for some reason. They give you this little carry case. It's not fireproof, so you can't use it as a charging set, which would be nice if it had been, but it's very nice all the same. All the others are cardboard, various sizes from quite small to the CENTRO one is huge. But secondly, I had to look at all the paperwork that comes with them. They all come with a bit of paperwork except for the Ludicrous ones. I haven't looked up on the site if there's any information about charging, discharging or whatever on their site, but there's no paperwork in it. All the others have some form of paperwork. Some of them are quite easy to read, nice print and everything, but there's a lot of waffle and blurb in most of them, which most people wouldn't read through. The print is pretty small on some, as long as you've got reasonable eyesight. It's a bit short, some of the info. It's in 2 languages on this one, and small print. Some are a bit better quality paper. All sorts here, ARROWMAX, CENTRO, Now the IP one is not very good. It just tells you do not eat it and stuff like that. Do not short circuit. It doesn't actually tell you any information about charging it or discharging it or temperatures, nothing. So it's not that useful. The Nosram LRP comes with a huge sheet of very small print in multiple languages. Look at that. You need a magnifying glass to read that. Anyway, to save you the trouble, I went through it and gleaned some information. It was also weird to find that most of them talk about dimensions in millimeters and weight in grams, but temperature is in Fahrenheit. I mean, mixing their units is odd. I assume they do that because of the American market. They still work in Fahrenheit, not centigrade. So a few of them use centigrade. So I've converted from Fahrenheit to centigrade. Now, just in conclusion, what I found, a couple of facts, was that they seem to say that 71 degrees centigrade is the absolute maximum temperature that you can use before the battery might be damaged. 71 maximum. And then charging and discharging, it says do not exceed 45 degrees centigrade, and they say they don't work very well below 0 centigrade, 32 Fahrenheit. I gleaned a little bit more of information about temperatures, but they all seem to say that. But I was looking for the charge rate and discharge rate. They all vary, so I made a chart about what I could find on the charge rates, how the maximum charge rate, for instance, that they either recommend or say you should use. And CENTRO, you said they're using 3C. Now that's an 8,000 milliamp hour battery, so that's 24 amps maximum charge rate. None of them talk about the discharge amps, but they do say you shouldn't exceed 45 degrees centigrade under discharge. And generally 71 degrees centigrade is the maximum allowed. So in some cases they say 66 degrees centigrade. So they seem to vary from between 71 and 66 depending. Optipower, they say that you can use 3C, which is only 16.8 amps for a 5.6, and they just mention 40 degrees C is the maximum, which is quite low. Anyway, quickly going through, CENTRO said 3C. Now Fantom, they say recommended charge 2C, maximum 5C. So if you took a 5C maximum, that's nearly 40 amps, 39 amps. So that's the highest one that anyone mentions in their blurb. This is the Fantom blurb here, and it says charging process. They all talk about maximum volts, etc. Normal charging. Charge rate should not exceed 5C. 2C charge rates are recommended for longer battery life. So I don't know what they're referring to, that 5C is going to wear the battery out. They do talk about discharging, do not discharge battery below 3.3 volts under load. I found that there used to be 3 volts, now it's 3.3, and they actually recommend some of these people 3.5 volts is the minimum. But when I test, I'm taking them down to 3.0. And quickly going over the rest. Silverback, they say 2C. Intellect, there's nothing on the sheet about charge rates, so I don't know what their charge rates be. So default will be 1C, which would only be 8.2 amps. Sunpadow says 1C, which is only 8, I don't know why I put 16.4, which is only 8.2 amps. LRP is 3C, as Nosram is 24 amps. Ludicrous, we don't know, there's no sheet with it. ARROWMAX is 1C, 8 amps, which would be the same, which is weird because the ARROWMAX we don't have, it's 1C, but it does say on the information Optipower 3C. So the Fantom and the CENTRO are actually the same battery. One says 3C, and the other says 2 or 5. So even the manufacturers don't agree. So that is quite confusing. 1C is safe, 5C is if someone says you're charging too high a current. If you've got the sheet from Fantom, you can show, no, it says 5 is fine. Couple more comments about the instructions and the charge rates, etc. I did notice that the Optipower sheet says charge between 1C, not more than 3C, 1C recommended. But actually on the battery itself it says charge rate 1C to 4C max. Also, I did manage to find online the Ludicrous instruction sheet, which there was nothing actually in the box that it came with, and I found I couldn't find the 1S one. It's more general instruction sheet. It says 2C, it says 1C recommended, 2C max. Do not charge above 4.2 volts per cell. And it says do not discharge below 3.2 volts per cell. Oh no, it's 1C to 2C, which I can put on this chart. I've updated the Optipower to 4C. Intellect, I looked on their website, it doesn't say anything much more than on that piece of paper that comes in there, so we have to assume that 1C is always the default, which would be 8.2 amps in that case. A lot of information, hopefully that helps. So that is that. Now, how do I test them? Well, I've got the load, the resistive load, 43 amps it takes. I've got a watt meter, but this is very useful because it measures milliamps passing through. I've got an accurate voltmeter, which I adjusted. It's got a little trimmer to read the voltage, and that is connected directly to the terminals which plug into the battery. So I can read the voltage directly on the terminals and get a pretty accurate voltage at the terminals. So I can measure the battery voltage as it, when I plug it in, so it's discharging versus the milliamps like I did last time, and I get a huge chart of results which I'll show you later. And on here I've got, I weigh the weight, do the size, and then I measure the voltage under load at various milliamps. Initially it's fully charged, I'll show you that in a second. I plug it in, the voltage drops immediately to a voltage around 4. But the first main reading is 200 milliamps, which represents after you've done about a lap or over a lap. And the higher the voltage, the quicker you'll go, obviously over the first lap or so. Then I measure it at intervals up to 4000 milliamps, see what the voltage is there, which is well past the end of the race for most people. And finally I measure the capacity when it's fully discharged, 3.0 volts from fully charged. Obviously try and get a capacity, and also I'll just check the temperature on the case afterwards. I do the temperature when I start and try and get it close to ambient as possible. There is a very small heating when I take it off the charger. Now I've got the iCharger I use. I cycle them up, make sure that they're all ready, and then I go through a procedure. I charge them up, I discharge them, and then I charge them fully, and I take them off and I test them. And at the same time on the iCharger you can get readings for the milliohms. Milliohms give you an indication on the iCharger. It's not 100% because every time you do it, it varies slightly. It depends whether you do it straight away, whether you wait an hour or so, or whether you charge it and then discharge it without cooling it down, etc. And so the resistances only give you an indication of how good or bad they are, and they're all pretty low. Some actually come out a lot lower than others. Can use it as an indication, but I don't find it as accurate as measuring the voltage under load. So I will show you one test so I don't bore you with them all, and then I'll go through the results. I did do an additional test of trying to heat the battery up before I discharged it to see if that gave any benefit. And I also took a 5mm battery and put a 4mm adapter in it and used a 4mm plug to see if it lost any voltage through the adapter, or whether the 5mm was better. Now some of these batteries are rated at 100C, some even boast of 150C, but I didn't take a lot of notice of that. None of these batteries can be tested at that sort of theoretical discharge limit, and the way they're connected inside to the sockets and the resistance of the sockets, the wires, the connections, will make more of a difference than this theoretical figure, which manufacturers will have worked out from the actual Lipo sack without any connections on it, and that's what they could theoretically get from it. But after they add the connections and whatever, obviously it's not going to be able to provide that sort of current without burning the connector and the wires out. So it's probably a theoretical limit, and maybe just made up in their heads, because 100C, some are 100, some used to be 90, some are now 120, 130, 150. I think it's all a bit made up, like the graphene name. So that's that. Over there is I just use that iCharger, which a lot of people have, with a high power load, so I can do 20 amp charging, 40 amp discharging, and I can cycle them up and test them and make sure that they all go through the same procedure, so there's no one that is done differently to the others. If I think something hasn't come out right, I will retest it once, maybe even more than once, if someone reckons that the result is good enough. Finally, I will mention that I did mention already that these are all about 8,000, 7,800, 8,000, 8,100, 8,200, and except for the Optipower, which is 5.6, I did ask them to provide me a bigger one. They did respond, and just to cover myself, to show that I did the best I can, Optipower says there's a lot of exaggeration in both C rating and capacity, which we know is true. Optipower have always been truthful in the available energy. In their dyno testing, we achieved over 10,000 milliamp hours. Well, he's referring to this 5.6. It will look potentially a little large to put on the label. Well, it's either 10,000 or it's not 10,000, so that's up to them. And he says it's confident that it will compare nicely on true capacity relative to the competition. And there's a graph here supplied which goes 1C discharge graph. For 1C, that means that they discharge it at 5.6 amps up to 11,000 milliamp hours at 3.5 volts. There's no way any of these batteries get at 3.5 volts, even the 8,200 gets to 11,000 milliamp. Anyway, that's just covering myself on the Optipower, because the results speak for themselves. And finally, I'll go through one of the procedures with one of the batteries, just because it's boring, and then I'll go over this complete sheet. Hopefully I'll be able to do the ARROWMAX by the time I show you the results. One more thing about these batteries I should mention is that most of them are still Lipos that say 3.7 volts, which Lipos have been for a very long time. A couple say 3.8 volts. You probably can't see that, 3.8. I did make a note of which one said 3.8. There was only a couple. The IP was one, the Intellect IP. The Silverback was the other one that says 3.8 at 100C volt series. I've only charged them all obviously to the 3.7, which would be a 4.20 cutoff on the charger. The 3.8 ones do allow you to charge a tiny bit more voltage, which will give you a tiny bit more capacity as well. On the Silverback sheet here, it does say cutoff is 4.35 instead of 4.2. So, but we don't use that. You could use it in your own personal use if you were just messing around with no rules. At competition level, we use 4.20, but it does mean that they would get a little more capacity if you charge to that level. Interestingly, 2S batteries tend to be the higher voltage rating now, but these 1S ones, except for those two, have kept to the original 3.7 volt. This is the procedure I go through. This has just come off charge, fully charged. I put it on as quickly as possible. You can see the meter is reading 4.19. I've got this battery just supplying this for the watt meter and the milliamps. And I've got the chart here where I can record all the voltages as it goes through the various milliamps. We start, the very first one is 50 milliamps. After we start from 4.19, I check the temperature of the battery just to make sure that it's not too hot or cold. It's about 23 degrees, and then I connect up the load with this heavy duty connector here, and I'll start monitoring the results. So that goes in, and at 50 milliamps it was 4.05, and the next one I'll take is 200 milliamps, which comes up pretty fast, is there, 4.01. And I'm going to do 500 milliamps, which is just about to come up. It'll be 3.98 or 97. It was just before. 750 milliamps is next. Let's try and zoom in a bit. Just coming up to 750 milliamps. There, 3.95. I'll try and move this into the screen a bit better. And I'll keep going. Thousands coming up next. Comes up pretty fast. I mean, in some classes you'd be at least halfway through the race by now. 3.92. And then some of the lower classes, 17.5. It'll probably be ending at 1500 milliamps, which is the next one I'll do. The voltage obviously measured directly on the battery terminals, and the capacity is shown up in this window. Then I'll keep on going until the end. Just coming up to 1500. I'm writing it down on the chart as we go. 4849 there, 3.86. I just zoom back out a bit. I've got the chart here, and I'm writing the results directly down. The batteries here. Yeah, the connectors go directly to the terminals on there, so we're getting the best voltage reading I can get. This particular battery's got 5mm sockets, which I found gives a tiny bit better voltage than the 4mm. Coming up to 2000, it gets through it pretty fast. Line there, 3.82. I'll do the readings up to 4000 milliamps, and then I'll let it go to the end and record the actual full capacity when it hits 3.0 volts on the meter. Just coming up to the 4000 mark. there, 3.72. It's just coming to the end of the charge now. You can see the voltage is dropping rapidly as it goes flat. So we'll take it off at 3, which is there. And the capacity, impressive, 8,276 at 3.0. And I can check the temperature. They generally always seem to be in the 40s. I'll just measure it on the case. 43.8. The heat does come out a little bit. So I'm right. As you leave it, then they cool down again. So we put 4 degrees. It's typical. That is the ARROWMAX 8000. And before we compare how it did, because their sheet says this is the only one, the best of the best, no compromise, perfect no matter in stock or mod. If it's related to 1S racing, this is the pack to have. Now it says it's 160 gram, 160.4, so pretty close. The results are what we're all interested in. These are the 1S Lipos I've tested, and this is a sheet of all the results. A lot of information on here, but I'll break it down into the bits that we're mainly interested in. And in this case, for Competition 1S racing, it's which battery gives you the holds up the voltage the best under load throughout the whole race. And we're going to look at the discharge milliamps versus the voltage. There's some other things I'll talk about in a minute, but let's get down to it. I tested some 1S batteries a year or so ago, and they're all very much a muchness. Have they improved? And I can say the very latest ones have managed to eke out a little bit more. And just briefly, I'll just show you before I show you some of the other figures, because you want to get straight down to it. Let's look at 1,000. Let's get a bit closer. 1,500 milliamps, which is, you know, quite way into a 1S race, and when you still want to be getting maximum performance out of your car, all other things being equal, which means you want the 1S Lipo to be holding up the best voltage. Now, some batteries from last year, the Intellect one's been around a while, and was one of the best batteries I tested before, and it was holding 3.81 volts. The Nosram's been around about a year as well, and that was holding 3.80 volts at 1500 milliamp discharge. And looking down the chart before we look at what the batteries are, you can see this battery here about the same. This one's fractionally better. This one's not so good. And then we got a jump here. I've tested it a couple of times. 3.86. That's it doesn't look like much, but these small increases in voltage do show up when you're driving the car. 386, 385, 385. This one is back to 382, and right down the bottom here, 386, 3.86. So these few here have definitely improved, and they are the latest ones that have come out. If we look across here, the Fantom 7800 is one of the good ones. The CENTRO 8000, and I said earlier in the video that I reckon they're exactly the same battery, just with different manufacturer stickers on them. And another one that holds up really good voltage was the LRP 8000, and that's a recent one that's just come out at the end of 18 as well. And that Silverback one's been around a while, so slightly lower voltage. And the ARROWMAX, the very latest one that they say is the best of the best, 386, and I think that was close to the voltage. I got a 386 from the Fantom as well. Now, looking at some, so those ones, the latest ones that have just come out, the Fantom, the CENTRO, the ARROWMAX, definitely gives the best voltage under load. We'll look at some of the other voltages later. So let's look at those three batteries, the CENTRO, there's one, the CENTRO there, and the ARROWMAX, the Fantom, the ARROWMAX, these three here. One thing you notice, they've all got 5mm connectors on them now. All the others are 4mm. So I think there's one way you can tell if they're the latest batteries that have come out, if they've got 5mm. And I did do a test where I reduced these from 5 to 4mm, and I did find that it lost a little bit of voltage. It's on one of these tests here. The CENTRO, I used the 5mm along there, and with the 4mm adapter here, redid the test, and at 1500 it dropped from 385 to 383. Not much, you reckon, and most people probably wouldn't care about that, but if you're trying to get the best, it did. And I did the Fantom as well. It dropped the same. A small drop in voltage just through that connector, the resistance of that connector. Now, let's look at a couple of the others. I retested a few of them where I thought the result wasn't good enough, just in case I hadn't done it right. But most of them, I've already cycled these and tested them after all the same way, and they're pretty accurate, these results. Before I look at, for instance, the cost of these batteries, one thing I noticed is a lot of information here. I've talked about the plus and minus connections. Most of them are the same way round, plus that side, minus this side. A couple of them are the opposite way round. The LRP and Nosram, which I said, had there been an improvement, because the Nosram's been about, this one's been about a year, and this is the latest LRP one, and they did manage to improve that. Nosram there, 3.80 I got at 1500, and the LRP, which is down here, you managed to get 1500, 3.85. Some more results you may or may not be interested in. The weight, I've written down all the voltages here and whether they're most of them are 3.7, a couple are rated at 3.8, but I only ever call them 3.7. The C ratings are all over the place, from 100C, etc. The very latest ones, though, CENTRO, they still say 100C. The ARROWMAX says 120C, and the Fantom says 100C, but they are very similar in performance indeed. One thing you can see, the dimensions, I did mention all the dimensions, they're pretty much all the same, the actual physical size, so I won't bother to go into that. But the weight varied slightly. The weight seems to have gone up a little bit from last year or a year or so ago. For instance, some of them, the Intellect only weighs 150.4 grams, and the latest Sunpadow weighs 163.1. And these ones down here, the CENTRO 157, the Fantom 157, you can see identical weights, the same battery, and the ARROWMAX 160. So they have increased very slightly in weight, but it's not a massive amount. The connectors, as I said, they're all 4mm, except the new ones that perform the best use 5mm connectors. Now, getting on to a couple of other things. The capacity, they're generally 8,000, 8,100, 8,200, 8,200, 7.8. The new ones, the CENTRO 8,000, the Fantom says 878, and the ARROWMAX says 8,000. And the only one that was way down on the others, the Optipower 5.6, which we've discussed earlier on. They say it's equivalent to these high capacity ones, and theirs is the only true capacity, and all these others are exaggerating. Well, we'll have a look at that in a second. So I won't go over all the voltages, but 1500 is a very important value. You might want to look at the 200 milliamp reading here, which is perhaps the first couple of laps when you want to be going at maximum speed. And 397, 399, 396, 391, and then you get down to the Fantom. I tested that a couple of times. It was 402, that was good, and 4, the LRP 401, and the ARROWMAX 401. Oops, way down there, ARROWMAX 401. It's still off the chart, sorry. Let's try and do that again. So the new ones hold up a slightly better voltage, 401, 401, 4.02 compared to the previous ones. So even on the first lap, they are delivering more voltage, more power. So there has been an improvement. Now, I did do all the actual capacities of the batteries. The 3.8 volt ones, which are a couple, would have higher capacity if they were charged to the higher voltage, which would give you a bit more runtime, but I didn't do that. There are a couple of Ludicrous ones up here, the Race and the Extreme. I didn't really find any difference, except one is just about 11 grams heavier. The voltages on those two, but basically the same. Well, they were the same, and the capacity was slightly higher on the one that weighed a bit more. Managed 8,326. I take the capacity right down to 3.0 volts, so that is the absolute maximum milliamps you can get out of a battery from fully charged to fully flat. The previous Ludicrous Race didn't quite make 8,000, but the Extreme got over. Tested it twice, and one tested it twice through, and one was about 100 milliamps more. Temperature wise, at the end of all the discharges, you've got they all come out around about over 40 degrees, some a little bit higher, but it depends. The heat does come out a bit, but they all ended up about 40 degrees, in mid 40s. So that's the temperature. Now the capacity, carry on. The Nosram was supposed to be an 8,100. I only managed to get 7,634 out of it. The Intellect 8.2, but that came out as 7,511. If you charge it to higher, you would have got a bit more. The Sunpadow is a good battery, rated at 8.2. Held up the voltage very well. Not quite as well as the very latest ones. That made 8289, almost spot on its capacity. The Fantom 7.8 made just over 8,000. The CENTRO 8,000 made almost identical. So the Fantom are doing themselves out of a rating. They're calling it 7.8 when the CENTRO says 8,000, because they both are identical. 799 68022 I retested, 7965 8072. The LRP 8000 also made 8,122 above its 8,000 rating. The Silverback, which has been around a while, the 8,000 was way off. I could only get 7,245 out of that. And the very latest ARROWMAX, which is supposed to be the best of the best, made 8,276. So it really is delivered on capacity as well as voltage. The internal resistances I mentioned earlier, that I get the charge and discharge resistances off of the IR, the iCharger. They are variable depending on how you do it. I tried to get them as accurate as possible, and the latest ones are definitely gave lower readings. CENTRO 1.4, 1.3, 1.3 milliohms, and the ARROWMAX 1.4. Silverback came out low, but as I say, these low resistances are also low. It's quite difficult to get a repeat performance out of the iCharger when they get that low. And the final one I mention is the Optipower. They said it should be the same, or if not better than all these others. They rate it at 5.6 on the label. I managed to get 6,379. It's nowhere near the 11,000 they said it should give, and it is significantly less capacity than the others. It weighed a little less, 146 grams, which means they lost some of the capacity just in the volume of the cell inside. As far as the voltage goes, it didn't hold up the voltage as well as any of the others. It was the lowest of all the ones I tested. And I also heated this battery up to see if I get more out of it. I heated it up by charging it, discharging it, charging it at 20 and 40 amps. I managed to get it up to 26 degrees C to start. I couldn't get it any hotter with those charge rates, discharge rates. It improved, as you can see, by heating the cell. You do get an improvement of the voltage, especially at the beginning. Managed to get it up from 391 to 397. 200. I managed to get up from 391 to 397. Yeah, it's quite impressive by heating the battery up. It drops off after about 1,000 milliamps. There's not much in it, so it's only right at the beginning of the race, 3, 4, 5 laps, whatever. You'll see a small advantage. Then it dropped back off, and at 4,000 milliamps, which is 4,000 milliamps, which is well past the end of most races or whatever you're using it for. Most of these batteries are around 366, 360 for the Optipower, and then the latest ones are still holding up good. 37, 371 and 372 down here for the very latest ones, which are the best. So in conclusion, from all that chart, all that information is that the latest batteries are actually a bit better. They do deliver more power, possibly partly due to the 5mm connection, partly due to improvements in manufacturing. But there's one more thing you've got to factor in: the cost. A year or so ago, most batteries cost about £40, 1S. £40, and the Ludicrous ones now, which you can buy directly, are still quite cheap, but the ones sold through distributors are generally now more expensive. The Optipower is still 40, but these new ones, the CENTRO, the LRP, the ARROWMAX and the Fantom, are all around £60 now. £60, £65, £60, £65. So there's been, in the UK, so there's been a massive jump in price on these cells from a couple of years ago, where you could pick most of them up for £40. But batteries last for a very long time now. They don't tend to wear out, from my experience, at all. You can keep using them and using them, and so it's a good investment anyway for a few extra pounds. But that's the results, best I could do, and I was quite surprised to find that the very latest batteries that have come out have made a small improvement in power, keeping the capacity high, but the price has gone up a little bit. And that's that. Those are all the batteries. It was a long test, and I hope it's given you some worthwhile information for when you go and buy another 1S battery.